Robotics is going to be the biggest industry in the history of the planet. There's going to be billions, tens of billions, hundreds of billions of robots of all shapes, sizes, descriptions running around doing all kinds of things.
Digitizing the physical world is probably one of the most exciting things about the physical world. It's just a physical manifestation of the AI wave.
We can run robots very fast through ditches, potentially break the robot, and then have a field team which is able to come out there and repair the robot faster than we can make changes to the software.
I am tired, Joe, of living in a biological body. I want robot. Do you want to build a company out of your garage with a wrench? Or do you want like 5 hyper-intelligent robotic assistants that are like, what do you want? Let's help you build it.
You've all probably seen, Elon has this Optimus robot that he's building, these humanoid robots. Like the general purpose robotics thing is going to happen, and it's going to happen in the next decade, and it's going to happen at giant scale. And I think there's a plausible argument, which Elon also believes, that robotics is going to be the biggest industry in the history of the planet. It's going to be gigantic. There's going to be billions, tens of billions, hundreds of billions of robots of all shapes, sizes, descriptions running around doing all kinds of things. Those robots need to get designed and built, right? And so my view is, we don't try to get the old manufacturing jobs back. What we should do is lean hard into the manufacturing jobs of the future, which is designing and building all of these new things, right? By the way, which includes drones and cars, right? And robots. We shouldn't be building manufacturing lines that have people sitting on a rubber mat for 10 hours screwing screws in by hand, but we should be building, what Elon calls them alien dreadnought factories, right? Which is like these super sophisticated factories with like tons of robotics. But you can imagine thousands and thousands of different categories of industrial production that have to happen all across the US in order to make this happen. And would cause just like enormous economic growth throughout the country. We get a huge payoff from all the tech investment that the coasts are making, but we generate many tens or hundreds of millions of jobs in the countryside. And then the U.S. would lead. It would be, be the third industrial or fourth industrial revolution. We would lead in the development of all these new things. And then you get to the national security side of this, which is if you don't do this, you're living in a world of Chinese robots everywhere. And that has, very profound consequences for, let's just say, profound consequences.
And it's an important policy point. And I want to dig into this a little bit more. I was just in an interview up there, like, aren't we going to destroy tens of millions of jobs? Isn't AI scary? A lot of people are very scared right now with the disruption. I'm very excited about the higher productivity because I see it being disinflationary. I see it creating more jobs. How do we, if assuming we're aligned, how do we explain this to people? How do we explain this is actually a really good thing for the country? Because a lot of Luddites are going to attack this. They are going to try to stop it.
Yeah, so the Luddites are wrong. The neo-Luddites are wrong. They're wrong in the sense of like for the reason they've always been wrong, which is the reality is we have not in the last 50 years been in an era of fast productivity growth, technological change. We've been in an area of slow productivity change, slow economic growth. AI, if it works the way that actually people either hope or fear that it's going to work, it's going to cause productivity growth to shoot up. That will naturally accelerate economic growth. But look, if it just stays as software, then the result of that is it's going to make the cities much better off, right? It's going to make San Francisco and LA and New York much better off and Austin much better off. But it's still not going to answer this question of what happens in the countryside. To answer the question of what happens in the countryside, you need to get to the next thing. You need to make AI hardware as well as software, and you're right back to that same prescription of basically reindustrializing the country. And again, not reindustrializing the country on the stuff that has already left, reindustrializing the country based on all the things that have to be invented and built. And it's just like we know. I'm just like incredibly highly confident that there's going to be these giant industries of computerized everything, AI powered all kinds of hardware of all kinds of shapes, sizes to descriptions. You're funding a lot of that kind of thing. I'm funding a lot of that kind of thing. I mean, look, the entire defense base has to get rebuilt around this.
We're gonna redo the manufacturing. We're gonna build roads and tunnels and everything cheaper. It's gonna be exciting.
Yeah, and so this is the thing. This is the thing to do. Like to me, the path on this is very clear because we have to do this because it's necessary from a national security standpoint. We have to do it because we need it. We need the economic growth. We have to do it because we need an answer for the entire population of the country, not just the cities. And we have to do it because if we don't do it, China's going to do it, and we don't want to live in that world.
We have a lot of entrepreneurs in the audience. Where do you see the biggest potential for startups around all of this stuff that you're involved in, fitness tech, nutrition, medical devices? Yeah. Assuming AI is not completely changing everything right away, we have some more years to build some companies. So what are the opportunities?
I think that after AI revolutionizes everything, we have even much bigger ability to build those companies.
I love that answer.
It's a positive. Like, do you want to build a company out of your fucking garage with a wrench? Or do you want like 5 hyper-intelligent robotic assistants that are like, hey, what do you want? Let's help you build it. Like, can you imagine like a man of your intelligence, if I could just clone you and have me as like, you'll be on my board of my companies? Like, why the hell wouldn't I do it? I just can't afford a billionaire to be on my shit. If I have robots like you running around in a few years, oh my God, like the world becomes unrecognizable. To that effect, we still have biological humans with biological problems. Short of genetic engineering just turning all of us into perfect angels and then us uploading our brains into the cloud, living there forever, Ray Kurzweil style, which I'm super down with. I think that's inevitable. A little crazy, I know. Healthy, super tasty, super filling snack foods. Right now, if you want a snack food, it's just going to be total shit unless it's a protein bar that tastes like also total shit.
Yeah.
Genius Shot is a step in the right direction. It's cool. It's not filling, but it's really healthy and it's really good for you. Imagine having candy bars that through advanced biotech are gigantic, taste amazing, and are really filling, but have perfect macronutrients and micronutrient profile. It is possible. Anyone who's getting into the space is going to see just a lot of huge upsides. As once people are getting over the obesity thing with the modern obesity drugs, well, Joe, they still need to eat food, and maybe they don't want to eat total junk. Another big upside, I think, is revolutionizing. What is it like the entrepreneur thing to say here? An industry rife for disruption, right? Am I doing that? Yeah, I'm an entrepreneur. See? The exercise machine world. Exercise machines like leg presses and hack squats, they're like the biggest revolution for those was in the 80s, and they've to some extent have arguably gotten worse since then.
Yeah, they're expensive and they're not very good for them.
Gigantic, way too much metal. If anyone is listening to this and you're an entrepreneur and you want to get in, if you have an engineering background, if you have a manufacturing background, 3D printing background, legit, please hit me up because we're probably starting something soon here in a bit. I have the know-how.
I'd love to invest in that. That sounds smart.
There you go.
Let's do it.
We'll talk later. See, here's the thing. If I don't get to this problem and someone solves it before me, good, thank God. I will rep your machines on my YouTube channel. Please, for love of God. That's a huge one. My last one, I have to throw this in there. I'd feel bad about it. Cybernetics. Now, this is real wacky, but the problem with this arm is it's cool. It's nice. And if we solve its aging, and if I reverse age to 22, I'll have jacked arms and they're quite capable. But software and hardware advance at exponential machine speeds. Biology in humans advances at evolutionary speeds of like every 100,000 years, you get a little bit of a difference. I am tired, Joe, of living in a biological body. I want robot arms. God damn it. The way I think this industry is going to progress.
You've explored, by the way, the limits of a body more than most people, I guess. So it's fair for you to feel this way.
For sure. Yeah, like just lift more. Like, what do you mean lift more? It's all I do with my time. So if you have a situation, I think it's going to start with amputees and some of the stuff like Elon and his teams are doing with like brain machine interface. It's actually a tractable problem now, which is so crazy to see in 2025 that the impulses of your nerves can be completely understood by a machine interface so that you can eventually have an arm, probably in just a few years, that if you get your arm lobbed off in an industrial accident or chronic masturbation problem, something I struggle with, then what happens is right now they give you an arm that like is cool, looks sort of aesthetic, but kind of sucks.
Yeah.
In a few years, it's going to be amazing. But here's the real kicker. A few years later, people who have lost their arms through amputation, for example, or their legs, their replacement parts will be better than biological
You're gonna have
parts.
better arms. Yeah.
Just better. And so at that point, I'm kind of like looking at a hacksaw, looking at and tying myself off and be like, here we go. I got to get Medicare to pay for this. But for all serious purposes, the cybernetic revolution, I think, is going to be massive. Eventually, humans can just be, first of all, safer in the world. Here's the thing. Right now I get into a car, and let's say it's a self-driving car. Thank God for Elon. And the probability of an accident is tiny, but there's still drunk, stupid people on the road. They sideswipe me. I'm very soft by machine force standards. Yes. Like, I don't care how jacked I am. 70 miles an hour is going to do some fun, omelet type of things to my body.
Yeah.
If I can be in a body that is cyber enhanced and I can have parts of my skull or the whole thing augmented with really like profoundly strong metals and auto stabilizers, I get into a car accident, bounce around on the freeway, wake up. Oh, my arm's missing. Who cares? Get it replaced. Keep going. That's the world I want to live in, man. I'm tired of being a meat sack.
Building off-road ground autonomy seems like an extremely difficult challenge because you don't have the same massive data sets, right? All these other car companies doing self-driving, there's these annoying cars that were driving around Silicon Valley for a decade, and they were kind of funny because if you try to pull in front of them, they'd have to stop because it'd block everyone. But these things were driving around forever gathering data, and they had so much data that I'm told that eventually was able to be key in training the models. You're going to have different environments every time. It's never going to be quite the same with the land. I mean, and is it also just a massive data problem, or what else are you doing for this?
It's extremely challenging. So a lot of robotics, and in particular field robotics, is essentially a combination of relying on your knowledge of physics and the environment and data. So you're using machine learning in the perception system in order to try to predict what the terrain looks like. Let's say, behind trees or underneath vegetation, you're trying to predict areas that you can drive through and areas that you can't.
You have to guess like how strong the ground is, I imagine, right? Because some ground's going to slip away and some ground's not, right?
Well, you have to contend with that somehow, and that can be very difficult because it can be hard to tell from a distance. And so, you can only really do as well as a human driver trying to do something similar. And often, what we'll do is, if we are moving into terrain which is a little bit surprising, our planning control systems adjust instantaneously to try to either get traction or find a different way through the terrain.
Is there ever something, it's a silly idea, but if there was something that was complicated, would you ever like send ahead a drone to look at something to make sure? Because you're like, oh, I don't know what that looks like there.
Well, that's a great question. It's actually not a silly idea. I mean, I think that a lot of folks are thinking about things like this. So, combining different types of robotic assets, whether they're like UAVs or ground vehicles, and using the sensors on drones to provide a better picture of the environment, which will then help the ground vehicle to move through the environment more effectively.
Awesome. And some of these vehicles, they're going 30 miles an hour, going around ditches and fallen trees and boulders. Is that kind of stuff?
That's right. Yeah, we've actually gone up to about 35 miles an hour on a pretty wide variety of terrain. So this includes off-road terrain, so pure cross country where there's no roads at all, but we also go through double track and dirt roads. So they're pretty high rates of speed for terrain, which is very difficult.
And what's your, if we could ask, obviously it's secret, but what's your secret sauce? I mean, you don't like to say you won the competition, but you're the only one left. Everyone I've talked to, I can say it for you. Everyone I've talked to in the DoD, has said really great things and is really excited. You guys are the best, they say. So, you're iterating multiple times per week with software and hardware, different environments. Like how come you got to be the best?
Yeah, so I think you are starting to kind of hit on some of our secret sauce. And I don't mind saying it because it's a hard system to replicate. So basically, one of the things about robotics is it's basically software and hardware working together, and then field robotics and robotics in some of the domains that we're talking about requires that software and hardware to work really well in complex environments. People who are just kind of starting work in robotics often think that you can just do things in simulation, but they quickly learn that it is really important to actually run your software on the robot, and then, especially in field robotics, run that robot in the terrain.
So just learn quickly a lot.
Yeah, and so for us, we just kind of getting back to the secret sauce. We started out by building an extremely capable mechanical engineering and field team that allowed us to put robots in the field all the time, to iterate in the field with our software, and crucially to make mistakes. And so we can run robots very fast through ditches, potentially break the robot, and then have a field team which is able to come out there and repair the robot faster than we can make changes to the software. So this allows us to iterate just over and over in a wide variety of terrain, and just learn a lot about that coupling between software and hardware and terrain, and then take those learnings and build better software and better hardware. And so that really is the secret sauce, that continuous field testing, and that sort of field forward, that kind of way of thinking about the problem.
I love it. Well, having a top engineering culture that iterates quickly is similar to how Palantir and other companies work. So you guys, a lot of the top talent in the world, obviously crush these problems at Waymo. It's everyone's seeing what it's starting to do now. It's amazing. And you decided to move into construction and starting with excavators for the real world. So how did you make that shift? Why did you found Bedrock?
Yeah, so part of it was really appreciating how incredible those scalability capabilities we just talked about were, where you start with a beachhead, in Waymo's case was San Francisco, and now you have this flywheel where you're adding new capabilities, new geographies, new platforms, and setting aside the complexity of the public road driving domain, the generalization actually really works well. We saw an opportunity to apply that to a space that never had that type of approach in it, which is automation of specialized heavy machinery. And construction was a especially exciting place to start, where you have large numbers of machine types. They're all in these slow-moving, semi-controlled environments. You have astronomical amounts of work that needs to be done. You have an industry that fundamentally has these astronomical tailwinds, where manufacturing has to be like built at massive scale. You have onshoring of manufacturing, reindustrialization. Infrastructure is going through a refresh cycle where you have to repave giant amounts of roads. You have housing shortages. You have energy. So you have this huge demands. At the same time, labor is going the opposite direction, where you're seeing the average age go above 50. Up to 40% of construction workers are retiring in the next 10 years. And so you have this like crisis level pain in this industry that's like about double-digit percentages of our GDP. And it's a perfect problem for autonomy to help really diffuse some of these kind of constraints that are holding it back. And it's genuinely supply constrained. And it has this very similar properties where you have a lot of different types of machines doing very diverse types of work, but you have pockets of incredible volume of work that needs to be done that is incredibly well suited for learning and automation.
A lot of it's very repeatable, I guess. So it seems like in some places it's easier and in some places it's harder, right? So the thing that seems maybe easier to me is you're not driving with like tons of other cars around. There's safety still a problem, but it seems like maybe not as
way more controllable.
You can iterate a lot more if something by itself practicing. So it's like probably easier and cheaper to iterate and learn.
Yeah.
One thing that seems a lot harder to me is you're like moving on very uneven ground and weird hills and things which you don't encounter. And then you also have like an excavator where like maybe in some cases it hits dirt, some cases it hits rock, some cases it hits something that slips, everything moves. Like, so you have to like model all sorts of different things here.
Yeah, there's some gives and takes. So on the easier side, these are actually very, very significant where you can't launch a robotaxi as a legitimate product until you solve 100% of San Francisco. Mm-hmm. We can actually be very surgical on the product kind of categories and mixes of machines and capabilities and become incredibly competent at a certain type of work, for example, heavy earthwork for an excavator. And that has astronomical amounts of value. It's one of the most capable machines, one of the highest volume machines and highest utilized, and it's the hardest to learn. And there's jobs where that's all they do for a year, moving gigantic
just for a year, just moving things. So
setting a foundation of a factory, right?
So construction is like $2 trillion industry. Excavators might be some like, it's like 100 billion.
Yeah. So the way to think about it is that there's 1.25 billion hours of operator time operating these heavy machines just in the US. So 1.25 billion hours a year.
Wow.
That's massively constrained because there's giant amounts of jobs that just don't pencil out, and everybody has shortages, and every general contractor we talk to is turning down work that they can't handle. And that's just one foundation. There was a study we saw that there's something like $120 billion of excavation contracts per year in the US. Now this is everything, right? And excavators we're seeing are oftentimes like 25-30% of fleets. And so the fact that you can isolate the product side is a huge value add. Safety, you have a very slow moving semi-controlled environment. So the interactions that are at the core of the complexity for qualifying a vehicle on a public road, you now can actually have a much more controlled problem that for a variety of reasons, we actually can chop off a giant percentage of the complexity of safety. And the hundreds of millions of dollars it would take to reinvent a vehicle platform for public road safe driving, these machines are actually beautifully designed to where we can retrofit existing machines and go to market without a vehicle.
So you could take like something like a Caterpillar machine or whatever and just like put stuff on it and go.
That's right.
Use
Sensors, compute, and now the machine becomes autonomously capable for the situations it's cleared for. That surface area increases through software updates over time, and it can still be manually operated. And the product becomes the digital operator and the driver of these machines and all the services that you can kind of get beyond it. And so there you can actually start to gradually get that beachhead, and then you use this flywheel to add new capabilities, demolition, material handling, other more nuanced tasks, new machines like wheel loaders, motor graders, compactors, new types of work, and you start that expansion, but you can start getting a really genuine business from the very beginning.
Tell us about some of the problems with excavating. I'm just curious, like, what's the tech stack look like for when you're digging? And it's going to have different types of ground. Does it learn over time about the ground from looking at it, from digging it? Like, can you tell what's going to happen? Like, does an experienced operator know, watch out, this is going to slip, and you have to learn that too? Like, how does it work?
So there's maybe like two really big buckets of things that are super different and challenging about this. So one is the fact that you're like manipulating the world and you have these like interesting weird dynamics. The second is the interface on how you actually define it. So on the first one, you're totally right. There's this physics where you're cutting through earth, clay is different than different types of soil. You have rocks, you have like pipes, you have all these different things.
And if you screw up, you're just going to fall into it probably.
So you could, there's actually some pretty bad things that can happen. And so that's actually like pretty modelable. You can like, you see the terrain model of everything. You can model the physics, what safe orientations you can be on. The harder part is probably what is inside the earth and how do you actually kind of
The pipe being there that you destroy.
yeah, the pipe, the rock, how do you not fight against it? How do you not cut fiber to DFW, right? Like, so apparently that's like, somebody told us it's like $1 million every few minutes if you cut that line or something.
Don't cut that line.
Don't cut that line. So there's like, they'll have a guy to just make sure you don't cut that line. So anyways, so there's stuff like that. But when you think about the interaction of the soil modeling problem, what's interesting here is that you can treat like the broader problem as like a giant scale imitation learning problem where like you're learning from expert kind of demonstration and you're learning the nuances of how to interpret this like kitchen sink of everything that's happening through massive scale data and picking up these nuances of how does this actually, how would you actually navigate these challenges? Very similar to how in a way we can kind of learn from human demonstration how you navigate the kitchen sink of stuff that's on a public road. And so in some ways the fight against the earth and everything, there's an element of that you just directly learn because you see how people react to it. And the sensor data you're collecting is not just the data from the top of the machine. We're actually seeing all the signals inside the machine that give you kind of the pressure gauges, the like IMUs, the resistance. You feel that resistance and the fact that you're not moving as much as you could. And so you can tackle it through directly learning. There's also a lot of things that we're thinking about in simulation where we actually have simulations that model kind of like different earth densities. And over time, you can actually even think about modeling kind of huge diversities of properties of Earth and just making sure that you're sufficiently able to navigate.
Yeah, I mean, you could say there's resistance here, there's resistance here. Oh, we found a large rock that's underground here that you actually have to change your strategy to remove this.
That's
rock.
right. You change your strategy, you change your pressure, you do all these things, and so you can treat it as a reinforcement learning problem to some degrees. And so there's all sorts of interesting ways to kind of like isolate this out. Where the interesting thing is about these physics problems is you don't even have to like perfectly model the Earth. You just want to be able to throw a diversity of circumstances and be able to kind of like test out your system. There's also, frankly, you kind of have you have this ability where it's not like a life or death thing where you can go and you can kind of like work through it and try to kind of like figure it out and push your way through. And
so because it's not life or death, you can iterate a lot more.
You can iterate a lot more. It can take you a little bit longer to deal with like some tough challenge. You can even get remote assistance if you like really need it. So you have a lot more flexibility on how you tackle these problems where it's not this like sparse situation where everything's fine and then suddenly you have an accident, right?
That's great because we talk about man-machine symbiosis as this thing we keep coming back to, which is the 1960s framework. People do what they're good at, machines do what they're good at.
That's right.
This is a lot easier way to work together, basically.
That's right. And these are meant to spice into existing fleets, and so so maybe this thing starts as like a excavator doing heavy digging tasks as part of a crew doing a heavy civil project in Texas, and then as this progresses, you start to go to more capabilities and more machines. And you still have huge amounts of work that has to be kind of like partnered and done. And in fact, it's expansionary because you're actually creating jobs that wouldn't be done otherwise, but you have an ability to kind of move higher and higher level and create almost like a operating system for a general contractor to define the work they want by the goal versus micromanaging the machines.